We can now move on to algebraic equations. The difference between an algebraic expression and an algebraic equation is that an algebraic equation has an equals to sign in it. Solve the following algebraic equations. So the first one we given here is x is equal to 10 minus 8. We're going to simplify that, put your constants together. So 10 minus 8 will give us 2. So x is equal to 2 there. The next one we have is x plus 5 is equal to 6. Now, to solve algebraic equations, we need all our variables on one side of the equals to sign and all the constants to be taken over to the other side. So if we look at this equation, we have x plus 5 equals 6. There are 1, 2, 3 terms there. Of the 3 terms, only one term is the variable x term. So we'll leave that term on the left-hand side of the equation. We have 6 already on the right-hand side. We'll take the positive 5 over as well to the right-hand side. So positive 5, when you take it over the equals to sign, becomes negative 5. Remember to change the sign when you're taking terms over the equals to sign. So now we have x is equal to 6 minus 5, and 6 minus 5 is 1. So x is equal to 1 there. Now if we're looking at HCF, LCM, and prime factors, we can start with the HCF, which is the highest common factor. So find the highest common factor of each of the following sets of numbers. Remember that a factor is a number that goes into another number without leaving a remainder. So the first example we have here is 8 and 12. If we find all the factors of 8, remember these are numbers that can go into 8 without leaving a remainder. So factors of 8 will be 1, 2, 4, and 8. Factors of 12 will be 1, 2, 3, 4, 6, and 12. Now that we have the factors of both our values given, we need to look for the common factors to both of them. So 1 is common to both 8 and 12, 2 is common to both 8 and 12, and 4 is also common to both 8 and 12. Now that we want the highest common factor, we need to choose the highest value of those common factors. So highest value that's common is 4. So the HCF of 8 and 12 is thus 4. If we're looking at the LCM, which is the lowest common multiple, we can start. Let's find the LCM of each of the following sets of numbers. Remember that multiples are sequential products of numbers. So if we have our first example, 5 and 6, if we look at the multiples of 5, multiples of 5 will be 5, 10, 15, 20, 25, 30, 35, and so forth. Multiples of 6 will be 6, 12, 18, 24, 30, and so forth. So if we're looking for the lowest common multiple, the only multiple here that we have that's common is 30 to both 5 and 6. So that would be our lowest common multiple. So lowest common multiple of 5 and 6 is thus 30. Prime factors. Remember that prime factors are factors that are prime numbers. Remember, prime numbers are numbers that have only 1 and itself as factors. So let's use the ladder method to find the prime factors of the following numbers. The first one given is 36. So when I use the ladder method, I always start with prime numbers that are the lower ones. So I start with trying whether 2 can go into my value. If 2 doesn't work, I try 3. If 3 doesn't work, I try 5. If 5 doesn't work, I try 7, and so forth. So I start with my lowest prime numbers and go higher. So into 36, I start with the lowest prime number, which is 2. Can 2 go into 36? The answer is yes. So 2 goes into 36 18 times. Then I look at 18 now on my ladder. Can 2 go into 18? Yes, 2 can go into 18 9 times, so I fill that in on my ladder. Now I look at 9. Can 2 go into 9? No, it can't. It's not a prime number that can go into 9. So I go with the next prime number, which is 3. Can 3 go into 9? Yes, 3 can go into 9 3 times. Now I look at the value of 3 in my ladder. Can 2 go into 3? No. Can 3 go into 3? Yes, perfectly. 3 goes into 3 one time. Now when you're doing prime factors using the ladder method, you must always end with a value of 1 on your ladder. Okay, so we do have our value of 1 at the end there, so our prime factors of 36 will be all the values on the left hand side of the ladder. So that's going to be 2 times 2 times 3 times 3. Those are my prime factors of 36.